All right, so I have a meeting today, so I couldn't come in class because I'm going to be in the meeting all day. I made this worksheet yesterday because I barely saw our quiz yesterday for the first time. And I'm like, all right, so I made a worksheet that has a lot of questions that are very similar, not exactly the same, but very, very similar to what you'll see on the quiz on Friday. All right, so I'm going to show you two ways of doing this first one. I'm going to show you the more difficult but right way to do it. And then I'm going to show you an easy shortcut that's going to work for your quiz. All right, so here we got our balance equation for aluminum reacting with oxygen gas to form aluminum oxide. So it's already balanced. 4 moles of aluminum will react with 3 moles of oxygen to make 2 moles of aluminum oxide. Now the question is asking, what if we increase the amount of oxygen from 3 moles to 6 moles? How many moles of aluminum would be required to get a full reaction, to not run out of one of these reactants? Remember, the reactants are what's on the left of the arrow. The products are what's on the right. All right, so here's the right way or the hard, more difficult way. Let's see if I can get my pen to work. Move that way. Okay, there we go. All right, so it's going to be a mole ratio. So it's line times line. So this would be the more difficult, but the right way to do it, not the straightest line ever. All right, so the question gives us, we increased it to 6 moles of oxygen. So we got 6 moles of O2. And it's going to be the mole ratio. We can see it here. It's 4 to 3. 4 moles of aluminum will react with 3 moles of O2. So we know it's 4-3. But what goes on top, what goes on bottom? We already know the moles of oxygen. We have 6, so we want to get rid of it. So the oxygen is going to go on the bottom. The 3 moles of O2 is going to go on the bottom. And the 4 moles, what we want to find out, the 4 moles of aluminum is going to go on top. Boom. Now we got our ratio all set up. And now it's just top times the top divided by the bottom. 6 times 4 is 24. 24 divided by 3 is 8. It'll require 8 moles of aluminum. All right, so that's the difficult or right way to do it. Now let me set it up and I'll do the easy shortcut. All right, so I showed you the right way to do it that'll always work. Now here's a shortcut that'll work for our quizzes and tests, because from what I've seen, our quizzes and tests are always going to have nice easy numbers like 3 and 6. And I'll show you why these are easy numbers. Because what do you got to do to go from 3 to 6? 3 moles to 6 moles are just 3 to 6. Now you could say add 3. 3 plus 3 is 6. You would be correct. But you don't want to do that. What you want to do is you want to multiply it by 2. 3 times 2 gives you 6. All right, so now we know that. So we go from 3 to 6 moles, you got to multiply it by 2. All right, well now, all you got to do is do the same thing to all the rest of them. So 4 moles is not enough to react with 6 moles of oxygen. To find out how many moles of aluminum we need, we just got to also multiply it by 2. And 4 times 2 equals 8. And if you look over here, that's exactly the same number we got when we did it the right way. Now, how many moles of aluminum oxide are we going to make? Well, we also got to multiply that by the same number, 2. And 2 times 2 is, of course, 4. All right, so this will work because it's nice, easy numbers. So we needed 8 moles of aluminum to react with the 6 moles of oxygen to create 4 moles of aluminum oxide. Now, the reason this works is because we have nice, easy numbers of 3 and 6. It's easy to tell. You know what you have to multiply 3 by to get 6. But what if it wasn't 6? What if it was like 4.5 or something? Well, then it becomes a little more difficult because what times 3 equals 4.5? Who knows? When you get numbers like this that aren't easy, like 3 and 6, then you got to do it the old-fashioned way. All right, so that's number 1. Number 2 and 3 are similar. So you're going to try to do those on your own. If you have trouble, ask your neighbor. And if you still have trouble, on Friday, beginning of class, we'll work on this. All right, we're on to number 4 and 5. Now I'm going to do 5 because it's more difficult. It won't be on the test. It's going to be a multiple choice. You're not going to be filling in any boxes. But I'm going to do number 5 because it's more difficult. I asked ChatGPT not to do this to me, but it did it anyways. I told him don't give me any coefficients in the balance equation, and he gave me this 2 right here. So I mean, on the quiz, it's going to be like this nice one up here where there's no numbers, there's no coefficients. So it's 1 mole of silver nitrate reacting with 1 mole of sodium chloride, 1, 1, 1. It's all 1. Here he gave me a 2. It really doesn't matter for this thing, but I'm going to do number 5. You try to do number 4. So the easy part is the substance. What are the reactants? So all I gotta do is look at the equation. Everything to the left of the arrow, those are the reactants. So our reactants here are zinc, and you can put 2HCl or just HCl. I'll put 2HCl. And what are products? What gets made, what gets produced? That's everything to the right of the arrow. So we got zinc chloride, ZnCl2, and we also get hydrogen gas, H2. All right, so we got the reactants and the products right here. Remember, this will be a multiple choice. You're just gonna have to select which of these. So you're gonna have like a box like this, another box. There's gonna be like 4 different boxes. You got to pick which one is correct. All right, so now we need to know how much moles we got. So where's my drawing tool? Found it. All right, so let's do the moles. Make sure I hold it perfectly. And all right, here we go. Oh, put it on drawing. All right, so you can see we got 32.69 grams of zinc, and 1 mole of zinc is 65.38. All right, so mole ratio, line times the line. So 1 mole of zinc, Zn, is, what was it, 65.38 grams. But we don't have 65.38 grams. We got less than that. We got 32.69. So we put that right here, 32.69 grams. And then it's just top times the top divided by the bottom. And if you do that, 32.69 times 1 is 32.69 divided by 65.38. If you do that on your calculator, you're going to get 0.5 moles. All right, so here, how many moles we got? We got 0.5. Basically, we have a half of a mole. All right, so now we'll do hydrogen chloride. Same thing. Line times line. How many moles do we got? So first up here is 1 mole of HCl. And you will not have a question like this on the quiz, so don't let this one freak you out. And 1 mole is 36.46 grams. 36.46 grams. And what do we got? Oh, we got 36.46 grams. All right, so if you need your calculator, you can do it, but you really don't need it. 36.46 times 1 is 36.46. 36.46 divided by 36.46 is 1. We got 1 mole of HCl. So we got 1 mole of HCl. Now, our products, I hesitate to even answer this because you're not going to need to know this on the test. So the mole ratio is still correct because remember, it's 2 to 1. There's no 1 here, but there's really a 1. 1 mole of zinc for every 2 moles of hydrogen chloride. We still have the same ratio. 0.5 is half of 1. 1 is half of 2. But since we cut it in half from 1 to 0.5 and from 2 to 1, we're going to get half the product. So we're going to get 0.5 moles of zinc chloride, and we're also going to get 0.5 moles of hydrogen gas. Once again, I wish this question wasn't even on it because something like this will not be on the quiz. It'll be more something like this. So do your best on this. Once again, ask your neighbors if you have trouble. And worst comes to worst, come see me at lunch, or we'll figure it out on Friday morning. All right, on to the next couple. All right, so after that last box question that I don't like, we get to some balancing equations. Not going to do one. We only got 4. It's mostly just trial and error, but if you need help with this, I can provide you with some resources, or just come on in. I can show you the beginning, like first 5 minutes of class. I can show you this, but there's only 4. I want you to try those. So I'm gonna do 7, and I'm gonna do it in 3 steps. So yesterday, if you watched the video I made yesterday, I think I posted it today. I did it the way you just do it all in one step. You just do it all at once. But here I'm going to do it step by step. Maybe you'll like this way better. So I'm doing 3 steps, and I'm going to pause at every step because my pen sometimes screw up. So this will take, I don't want to get like 5 minutes into it and then have to start all over. All right, so right now, I don't care about this equation. I don't care. I don't need it. I'm going to scratch it out. Don't even look at it. One step at a time. We're going to do the step we know. Right now, I don't need aluminum oxide. Don't need it. Just don't even want to look at it right now. All I need to concentrate is I have 50 grams of aluminum, and I need to know how many moles that is. We've done it before. So here it is. Step 1, I'll put a little 1 for step 1. All right, so it's line. Hopefully I have enough room. Line times line. All right, so we got 50 grams of aluminum. 50 grams of Al. We want moles, so mole goes on top. 1 mole equals, you can see right here, is 26.98 grams. This is going to give us the amount of moles of aluminum. Now I got my calculator here. Let's see. So 50 times 1, of course, is 50, divided by 26.98. 50 is more than 26.98, so we should get a number bigger than 1. Let's see what we get. 50 divided by 26.98. 26.98 equals, we got 1.85 moles. I'm not going to, okay, let me write it. Moles of Al. All right, so that's step 1. I'm going to go ahead and pause it and start step 2. All right, so I got step 1. I got to get my pen perfectly. All right, so now, unfortunately, now I need this stuff. Now that I figured out how many moles of aluminum we got by doing our simple ratio, so we want moles, that's why moles went on top. We got how many grams? We got 50 grams. 1 mole is 26.98. We got 1.85 moles of aluminum. Now, I'm doing it step by step. Now, you really don't have to do this, but it kind of shows you why. All right, so now let me get to drawing. Now I got to do the mole conversion. So I'm using this number right here. So I'm going to draw a line under it. So, all right, don't go too high. Line times line. All right, so now it's just like in a calculator, like 2 plus 2 plus 2 equals 6. You don't have to go 2 plus 2, then hit equals, and then put plus 2. You can just go 2 plus 2 plus 2. It's the same thing with this. So we really didn't have to solve that 1.85. We could have just kept going. But anyways, so 1.85 moles of aluminum. Now we do the mole ratio to figure out how many moles of, what are we trying to figure out? Aluminum oxide. All right, so we're going to figure out how many moles of aluminum oxide are produced. So we need the mole ratio. So aluminum is 4, aluminum oxide is 2. So we already got aluminum. So it's 4 to 2, what goes on top, what goes on bottom. Since we want aluminum oxide, it goes on top. So 2 moles of Al2O3, and then the moles of aluminum will go on the bottom, and it's 4 right here. So that's going to be 4 Al. So there's our ratio. 2 moles of aluminum oxide, 4 moles of aluminum. And then we could do it again. We can equal. So now it's 1.85 times 2 divided by 4. I'm going to get another answer. And let's see what my calculator says. So the top times the top divided by the bottom. 1.85 times 2 equals that, divided by 4 equals, I got 0.925 moles of Al2O3. All right, let me pause and I'll do step 3. All right, so now we're on to step 3. So step 1, we was just a simple mole conversion. We want to know how many, we have 50 grams of aluminum. We want to know how many moles that is. So we do a mole conversion. We put 1 mole on top because that's what we want to find out. We want to find out how many moles it is, so we put it on top. And 1 mole is 26.98 grams. We did 50 times 1 is 50, divided by 26.98, and we got this 50 grams equals 1.85 moles of aluminum. Now we want to know how many moles of aluminum oxide that is going to create. That's where the mole conversion came in step 2. So the number we got in step 1, 1.85 moles of aluminum, then we made our mole conversion. We put aluminum oxide on top, and it's number 2, because that's what we want. We don't want to find out how many moles of aluminum because we already got it. It's 1.85. So what we want to get rid of is aluminum. That's why we put the number 4 and aluminum on the bottom. So really all we did here was multiply. So 2 over 4, that's like 1/2. So basically we just took a half of 1.85 and we got 0.925, because this 0.925 is half of this. So this gave us how many moles of aluminum oxide. So we got 0.925 moles of aluminum oxide. I got to make a little space, so just trust me. That's 0.925 moles of aluminum oxide. And now we got to turn this back into grams. So let me get my little pen, make sure I'm holding it correctly, perfectly. Oh, I got eraser. Let's get rid of the eraser, go back to drawing. All right, so now I got to convert this to grams. So there we go. Come on, there we go. So I'm going to put a line under it because we always do this. Line times line. All right, so we want grams. We want to get rid of moles. So what are we going to put on the bottom? What we want to get rid of? Moles, 1 mole. All right, so 1 mole of aluminum oxide is 101.96 grams equals. So we're going to do like always, top times the top divided by the bottom. The bottom is 1, so that is not really going to matter. So let's go ahead and see what we get here. Oh, there we go. Get my pen working. So 0.925 times 101.96 equals 94.313. barely had enough room. 94.313 grams. Now I could divide that by 1, but 94.313 divided by 1 is still 94.313 grams. All right, so that's a long way to do it. Remember, you can look at my older video to see the shorter way to do it. All right, and like always, if you have any trouble, email me or come see me at lunch, and we'll get ready for that quiz on Friday.